Hello everyone. So today I will explain about how to arrange my ID using synchronous sequence using T flip flop and D flip flop. So first, this is a T flip flop circuit. So this is excitation for T flip flop. So here we have two input. So we can see when T0 Q0, the output will be 0. 10 Q0 input will be 1, and T0 Q0 output will be 0, and T and Q both 1, and the output will be 0. So my ID is 0107672. So here I will use 5 bit in this project because I don't want the repetition in my project. My ID has a repetition which is number 7. So here I make a state diagram for my project. So here is 0107672. So here you can see the repetition is for 7, which is this and this. So I use 5 bit to make sure they have a difference between the both number. I mean 7 and 7. So I put uh, 0 and 1 to difference between this number. So I use at the left side, I put 1 and 0. So here you can see my state diagram. So next, I make an excitation table for the circuit. So I arrange my ID like this. So you can see this is I get from the state diagram here. So present state, and this is next state. So 0 0 0 0, and next it goes to the 1, which is 0 0 0 0 1. So the bottom are same. We I put present state here, and this is next state until it repeat to 0. So this is output. So how can I get the output? I use the extension for T flip flop here. So we can see here 0 Q5 0 0, we got 0 0 1, we got 1. So I use the T flip flop excitation table to get the output here. Same as Q4, Q3, Q2, and 1. I use excitation table for T flip flop to get the output here. Okay. So from the excitation table that I got, I made a Carnot map, K-map, to get the equation. So here is T5. T5, I made a excitation Carnot map to get the equation. So here we can see 1 and 0, and the others box that do not have number 0 and 1, I put X as a to fill the empty box. Okay, so here I will group the the box to get the equation. I use base 2 for regroup the uh, output here. So I got 1, 2 and 3, which is this is for Q5, Q5, and this is for Q1 bar Q3. Yes, Q1 bar Q3, and this is for oh Q1 bar Q3, and this is Q1 Q2 bar. Okay, this is T4. What we can see from the extension table, there is no 1 here, so we just put 0 and there is no equation for this output. So this is T3. T3, there's only 2 number 1, so we can regroup the output just here. So this is Q5. The equation for T3 is Q5, and this is T2. This is Q1 bar Q5, and this is Q2 Q3 bar. Okay, this is T1 equation, Q2 bar plus Q3. Okay, so this is a circuit diagram that I have made in using circuit verse. So what you can see, the T flip flop shows 0 0 0 0 0 here. Okay, so I add some LED to easy for us to see the LED, that we can know which is what the number will be on in this circuit. Okay, this is ID equal to 0, which is first number in my ID, 0. So circuit diagram shows a binary 0 0 0 for ID equal to 0. Okay, this is ID1. ID1, from the circuit you can see number 1 is on left side. It is because actually this is T1. T1 is a LSB. It means LSB, but so and the T3, T5 is a MSB. So when we see at the LED, it is vice versa. So from this, you can see that it is 0 0 0 0 1. So it is equal to 1. This is ID equal to 0. So the T5 becomes 1. But the other 3 is 0 0 0. So ID equal to 0. So this is 7. ID equal to 7. So we can see here 1 1 1. So LED shows light up. It shows 1 1 1 for ID equal to 7. So this is ID equal to 6 0 1 1. But because it's LSB and MSB, so the light up is on left. So this is 4 2 1. So 4 plus 2 equal to 6. So 1 1 0. ID equal to 6. So this is ID equal to 7. 1 1 1 is become ID equal to 7. So this is ID. So this is ID equal to 2. So we can see here, this is 8. This is 4 2 1. So this is 2. So 0 1 0. It is equal to ID equal to 2. Okay. Okay. Next is a D flip-flop. So here we can see the circle for D flip-flop, and this is a truth table for D flip-flop. So the input is S and R. So 0 0, so it's no change. 0 1 reset, 1 0 set, 1 1 0. Okay. So this is excitation table for the circuit, my circuit, to get the my ID. So this is same and same. The output is only difference. It's because we if we want get the output, we will use the D flip flop truth table to get the output. So we can see here when Q5 and Q5 present state is 0, then state is 0, so the output is 0. Q50, Q51, it is equal to 1. But when the Q51 present state Q51, next state Q50, so the output it becomes 0. So the only difference between T flip flop and D flip flop is only the present state of the input 1, next state equal to 0, so the output will become 0. Okay, difference with the T flip flop, when present state input equal to 1, next state equal to 0, so it's the output will become 1. So here this is a scheme map for D flip flop. So from the output, I just put in the map to get the equation. So this is T5, this is T5. So from here I get Q1 bar and Q3. This is Q1, Q2 bar. Okay, so T4 does not have the equation because the output all the output is 0. So T4 equal to 0. So this is T3, Q1 bar, Q5 plus Q3, Q5 bar. Okay, this is T2, Q5 plus Q3. This is Q5 and this is Q3. So this is Q okay, this is Q2 bar, Q1. This is Q2 bar plus Q3. Okay, so this is my circuit diagram for D flip flop. So when ID equal to 0, the LED does not light up. So this is 0 0 0. So this is ID1 from the circuit. So the LED 0 0 1, which means 1 only at the first bit. So this ID equals to 1. So the ID equal to 0 0 0 0. This ID equals 7. All of the bulb light up. So 1 1 1. When we plus, we get 7. So this is ID 6. 4 plus 2 equal to 6. This is ID 7. 1 1 1. It means 4 plus 2 plus 1 equal to 7. So they're in the middle of the LED. 0 1 0. This is 2. So ID equal to 2. So this is T flip flop for my ID circuit. So first, this is 0 0 0 0. So when I clock, so it becomes 0 0 1. So the LED at the first bit will be light up. So when I clock again, it's become 0 here. Okay. I clock again, it's become 7 because 1 1 1s. When we plus 4 plus 2 plus 1, it becomes 7. So this is 6. 4 plus 2 equal to 6. So this is 7, 4 plus 2 plus 1 equal to 7. So this is 2. 0, 1, 0. So this is 2. 0, 1, 0. So this is my circuit ID for T flip-flop. Okay. Okay, this is a D flip-flop circuit. So the circuit shows 0, 0, 0 for my first digit of my ID. So this is 0, 0, 0. Then when I clock, it's become 0, 0, 1. Then 0, 0, 0. 7 plus 4 plus 2 plus 1 equal to 7. 6. 4 plus 2 equal to 6. 7. 4 plus 2 plus 1 equal to 7. 2. In the middle of the LED. So this is 2. So this is my D flip-flop circuit for my ID.